So now we're taking our second and last look at the ellipses that we started in the last video. I am, however, going to add some comments to the diagram I had you guys draw for the shape of the ellipse. So the first comment I have here is that the center is the midpoint of any of the pairs of points they give you in the examples. For example, if they give you the two foci, then the center, just find the midpoint of those two coordinates. If they give you the minor axis endpoints, which would be the points on the shortest distance across the ellipse, then you can find the midpoint, and that would be the coordinate of the center to give you h and k that way. Or they will give you the major axis endpoints, and again, if you find the midpoint of those, that will give you the coordinates of the center, so you'll know h and k. The second comment I have here is about the major axis length. If they give you the major axis length, that's basically the long diameter all the way across, the longest way across the shape. So if you cut that length in half, that would give you the value for A. So what I'm telling you here is that the major axis length is 2A, so A is just half of that length. Or I put the same thing just in parentheses here. If they give you the minor axis length, that's the short diameter, you can cut that in half to find the length of B. So depending on what they give you in the example, that's a way that you can find some of your missing variables for the A, B, H, or K numbers. Something else that will be helpful in finding your missing values for the A, B, and C values, the distance from the center to the major axis endpoint. So if you use the distance formula, or if you can determine how far that distance is, that is your length for A. The distance going from the center to the minor axis endpoints, the shorter radius, that is our length B. And I believe I showed you guys that in the last video, but there's one more length that's also useful for us to keep track of, and that's the distance from the center to either of the foci that they give you. That is the length of C. So knowing the distance formula or being able to determine those distances just by adding and subtracting the x and y values, that'll help you determine A, B, and C based on the coordinates that they give you in the different questions. So in this example, they've given us the location of the two foci. If we find the midpoint of them, which you can probably do without computing, but I want to show you how to use the midpoint formula since you probably haven't done it in a while anyways. So you add the x coordinates together, which in this case is 0 plus 0, and then you divide by 2. We're always dividing by 2 because we're taking the average of two numbers. That's what the midpoint formula does. And then you would take the y coordinates. So in this case, I have -3, and then I'm adding the other y coordinate, +3. And again, we divide by 2. Because I'm taking the average of two numbers. So average the x's and average the y's. That's the midpoint formula. In this case, it was a pretty easy one to do without writing it all out because 0 divided by 2 is 0, and -3 plus 3 is 0, divided by 2 is 0. So now I know that h equals 0 and k equals 0. Sometimes it won't be as easy to determine those numbers without writing it out though, so please make a habit of practicing using the midpoint formula. The second statement they gave me is that the minor axis length is 4. And the minor axis I was just showing you guys is the short diameter. So 2b equals 4. If we take half of that number, that's what b will be. So now I know h, k, and b. And there's one more thing I can determine. I told you guys that the distance from the center to either of the foci is the length c. Well, if you do the distance formula from 0, 0 to 0, 3, the x-coordinate didn't change. It stayed as a 0, so there was no length from that part. However, the y-coordinate went from 0 to 3, which means that c is equal to 3. That's the distance between those two coordinates. You could use the whole distance formula on those if you want, but since these are just vertically, one's at 0, 0, and one's at 0, 3, I'm just defining that that's a vertical length of 3 on our x and y axis. So now I know h, k, b, and c. The last thing we need is our a value, which again you can find from looking at the list of formulas we have. So I know that a squared is equal to, if b is 2, then b squared will be 4, plus c squared, and we said c is 3, so c squared is 9. So now I know that a squared is going to be equal to 13, which would mean a is the square root of 13 if you need that information. So we have all the values we need to write the standard form of our ellipse at this point. We really just need to be careful about which numbers get paired with which variables. Because I told you guys that a Sometimes it goes underneath the x value, sometimes it goes underneath the y value. Now, in this particular case, since our foci are going from 0, -3 to 0, +3, they're moving up and down, and A and C always go in the same directions. So if C is going up and down, then A is going up and down as well, which means I'm going to have my y minus k, which is 0, so I'm just going to write y squared. And then the a squared value is going to go underneath y in this case. And again, that's because A and C always go in the same directions. And since C is going in the y direction, it's going up and down according to the coordinates for the foci, then A does as well. And then it's going to be a plus x minus h, but we said h is 0, so just x squared, over b squared, which is 4. And then this always is equal to 1. So remember, for your ellipses and for our next shape, the hyperbola, it'll always be equals 1. You just have to pair together correctly the x, y, a, and b terms. Okay, here's another example where they've given us some starting pieces of information. Starting with the major axis endpoints, again, I'm going to use the midpoint formula to find the center from there. So if I average the x coordinates, that'll be -2 plus 8 over 2. And then I'm going to average the y coordinates. So -1 plus -1 is the same as -1 over 2. And then if you simplify those, well, -2 plus 8 is 6, divided by 2 is 3. And -1 minus 1 more is -2, divided by 2 is -1. So now I know that h equals 3 and k equals -1. Whatever coordinates they give you, major axis endpoints, minor axis endpoints, or foci, just find the midpoint. That's your h and your k value. And then the second piece they gave us is the minor axis length. So again, the minor axis length is the one that determines the b value. And since that's 2b, then that means b is half of that. So 4 is my b value. Now in the last example, they gave us the foci. So I found the distance from the center to the foci, and that was defined as the length c. This time they've given us the major axis endpoints. I told you on the previous diagram that the distance from the center to the major axis endpoints is the length a. So again, I'm going to try to find the distance from my center to either of the major axis endpoints they gave me. It doesn't matter which one you use. I'll use this one that's right above it, and you'll notice that again, one of the coordinates does not change. So I don't even have to pay attention to the y value because it does not change. So the x value, what is the difference from 8 to 3, or what is the distance between those rather? So in this case, the distance from 8 to 3 is 5. All I'm doing is 8 minus 3. I'm just taking one number and subtracting the other. So now I have that the length from the center to one of the major axis endpoints is 5, which is what we define as the a value. Since I have a, b, h, and k, I don't even need to find c squared, because if you look at the original formulas, you'll see that c squared is never actually used anywhere within the formula. It does affect some things, like labeling the foci, but if they didn't ask us for that, we don't need to find it. So instead, I can just go on to writing my equation here. What I need to be careful about, though, is again, which numbers get paired with which variables. This time, when I'm looking at the major axis endpoints, I see that it's the x coordinate that's changing. So this time, my a value needs to go with x. So my formula has x minus h squared. And then it's also got the y minus k squared part. So I'll go ahead and write that. Y minus -1 is y plus 1 squared. We also know that it's always going to equal 1. So here, again, just to reiterate this, since the major axis endpoints are going from left to right, it's the x value that's changing for them. That means I need to put a with my x variable. So it's not just a that goes underneath, though, it's a squared. So I'm going to put 25 down here. And then that means the shorter distance across, b, must be going with the y variable. It's not just b, though, that goes underneath, it's b squared. So I should have this for my standard form of an ellipse. So it'll take some practice. You'll start to get the hang of recognizing if the major axis endpoints have the x coordinates changing, then put a with x. If it's the y coordinates changing, then put a with y. It will change from question to question, so you have to look at that and be careful about it. as we did with the other shapes, this time I'm going to have you guys do the proof and figure out which shape is being presented here. It's harder and harder to tell whether you have an ellipse, a hyperbola, or a circle, since these all have x squareds and y squareds in them. But I will show you that there are some rules that let us tell at a glance without even going through the whole completing the square process. But for now, let's go ahead and group together the x terms. So I've got 9x squared minus 18x. And then I have the 4y squared plus 16y. And I'm going to move the constant to the other side of the equation. So I'm going to add 11 in this case. Something I hope I told you guys or reminded you guys about was that for completing the square, you cannot have a number out front of the squared variable. So I actually need to factor out the 9 in front of my x squared in this example. So I'm going to take the 9 out of that. And I also have to take it out of the other x term. So this will be minus 2x. And then I'll leave a blank space for where I complete the square. For the y's, I need to get rid of that 4 that's out front. So I'm going to factor 4 out. That will leave me with y squared plus 4y. And then I'll leave another blank space for completing the square. So for completing the square, take half of the middle number. That would be -1. And then when you square that, that's a +1. But here's kind of a tricky thing on this. When I need to add that number to the other side of the equation, I can't forget about the fact that I factored out a 9. So I'm not actually just adding 1 to the left side of the equation. If I distributed the 9 back through, I actually just found that it's 9 times 1. So I'm going to add 9 times 1 on this side of the equation as well. And then the same thing will happen for the y's. Half of the middle number is 2. If you square that, you get 4. But on the left-hand side of the equation, it's not just 4. Because of the distribution, it's 4 times 4 that I need to add to the other side of the equation. So don't forget to adjust the value that you're adding to the other side of the equation to maintain the balance. I didn't just add 4 over here, I added 4 times 4 because of the distribution. Everything else goes kind of the same way we've been discussing. It's always half of the middle number. So this will be -1 squared. And for the y part, it'll be y plus 2 squared. And then if I compute these, 9 times 1 is 9, and 9 plus 11 is 20. And 4 times 4 is 16. 16 plus 20 is 36. But I shouldn't have another number over here. This number should always be a 1. So whatever number you see, divide everything by that value. The formula for the ellipse, it has to be set equal to 1 for our standard form. So I'm going to divide everything by 36 and reduce those fractions. 9 over 36 is equal to 1 over 4. So it'll be x minus 1 squared over 4. And 4 over 36 is 1 over 9. So this will be y plus 2 squared over 9. And then 36 over 36 is equal to 1. That's why I divided by 36, because it gave me that number I desired right here. From here, we can actually list out any of the information they want from us. We have our standard form now. So when they say something like find the vertices, well, we know that our h and k values, h is 1 and k is -2. And then in this case, you might have actually wanted to switch the order on the x squared and the y squared, because as a hint, I was saying you guys should write the one with the bigger denominator first. It doesn't actually matter though, because addition is commutative. What's important here is the bigger number in the bottom is a squared. So that means a is 3 in this case. And then my b value is the smaller denominator. So if you take the square root of 4, that's 2. So I have hk, a, and b. From here, you can go through and use the formulas, or you can try to remember some of the shortcuts I've been trying to give you guys. If the center is 1, -2, I need to add the a value to the y coordinate, because a came from y. So my vertices, which is another name for the major axis endpoints, my vertices will be 1 and then -2 plus 3, which is 1, and 1, -2 minus 3, which is -5. The other thing they asked us for is the foci. For that, I do need to find the value for c. So I'll write this up here. Don't forget that a squared is equal to b squared plus c squared. So solving for c, I have 9 is equal to 4 plus c squared. If you subtract 4 from both sides, then you have 5 equals c squared, which means c is equal to the plus or minus root 5. So for the foci, it's the same idea where I'm starting from the center, my 1, negative 2 coordinate, but I'm going to be adding and subtracting the c value to the same value, in this case y, because a came from y, so c goes with y as well. So I'm going to add it to the same coordinate. So I'm going to have 1, and then my k value was negative 2, but I'm saying to add and subtract root 5 from that. And we can't simplify that, so it's okay to just leave it in this form. When I added and subtracted the a value to negative 2, that I was able to simplify. So I had 3 plus negative 2 and 3 minus negative 2, so I went ahead and computed those. But for adding and subtracting root 5, you can't combine the like terms, so it's okay to just leave it there. And that should be it for the notes. These are difficult questions, and it is confusing, especially when you're comparing ellipses and hyperbolas. So again, it helps to know some of those shortcuts. Make sure you know a lot of the basic things I was giving you on the original graph to help you identify what is A, B, and C. A is the distance from the center to the major axis endpoint, B to the minor axis endpoint, and C to the foci. So that'll be it for the notes.